Hello and welcome to Decimal Search Fail Case. When does decimal search fail? Well, decimal search works by locating a change in sign, so it will fail if it can't find the change in sign even though there are roots there. So if we draw a very weird cubic, like say that one, notice that here my y value is positive at -2, it's positive at -1. So when you do your integer search you can't actually spot these two roots, but there they are, we can see them on the graph. Now because we are doing decimal search, we would like this to fail at the decimal search level, not just the integer search level. So if I delete all of my scribbles and zoom in on the x-axis, what you want is that your two roots are in the same 0.1 interval. So for example that's a quite bad example because of the zoomed in version, but these two roots here are going to be the source of the problem, or the root of the problem if we're going to go for puns. So how can you come up with such a graph? Well, let's go back to our normal curve and enter an equation. Now if you enter a cubic equation, doesn't matter what you put much, just make sure that your coefficient of x cubed is positive and your coefficient of x is negative. That will definitely ensure that you have three roots. Would be an interesting question to ask you why. So there we have it, a cubic, it's a bit cut off there, we'll solve that later. Problem is these two roots are nowhere near what I need them to be. So what we will do is we'll move the curve up and play with this constant until I get it to where I need it to be. So let's zoom in a little bit more on this part, and looks like I need to move it just a bit higher up, so let's go for 1.5. Too much. Play a bit of trial and error. Okay, it's good, it's in the same 0.1 interval, not the same, it's in the same 1 interval, sorry, not the same 0.1 interval. So we need to move it up a bit. 0.3, not there yet. 0.35, don't think we're there yet, let's zoom in a bit more. 0.4, way too much. 0.37, 0.38, too much. 375, 376. I don't want one of the roots to be exactly 0.5, so that's what I'm a bit worried about here. So let's zoom in on this part, and they're not. One of them is here, one of them is there, they're both within the same 0.1 interval. Let's check the roots quickly. It only shows me the roots that I can actually see, and yeah, plenty of decimals, so they're not easily solved algebraically. Last thing we should do is check that the last root is not very nice either, and once I've zoomed out it puts it there. No, it's not nice, so that equation will do. I need to actually zoom out a bit and make my y a bit bigger because we need to see the whole curve. So now you can start actually describing what's happening and say, oh look, once I perform my integer search in Excel, or as you wish, you could do it here in steps of 1. I can see that there is only one change in sign, which implies we only have one root. However, we can see from the graph that there are 2 roots there, and you might want to actually zoom in and say, look, from the graph, not the very look there, from the graph we can see that there are 2 roots, but guess what? Integer search doesn't find them. There we go, that's a good illustration. Okay, next you might want to even go further and say, well, I know they're between 0 and 1, let me show you that it fails at the first decimal search as well. So go between 0 and 1 in steps of 0.1, and you'll have a table of values here that shows you there is no change in sign. Therefore, decimal searches failed to find these values. Remember to have your graph all labeled, and that should help with the last part of coursework. Thank you.